Hello all, welcome again in Java City. The agenda for today's video tutorial is to study drawbacks of synchronized block and multi-threading dealt by java.util.concurrent package. So the concurrency is a very important for any Java application dealing with millions of users which is updating a real-time data. So the application which is in coordination, which is in contact with number of users and is taking a real-time data updation, on that case multi-threading plays a very important role. So this package java.util.concurrent package provides number of interfaces, classes and lots of utility methods for handling multi-threading and related issues. java.fx.concurrent package that leverages existing API with the constraint of GUI application. Some GUI application in JavaFX runs in a main thread, JavaFX application thread. And what happens if any big application or a data source browsing takes place in application thread? So on that case, the GUI application becomes unresponsive, and this is completely undesirable for a good GUI application. So lots of data browsing and working with databases takes place in a background with the help of number of background threads, and that code they coordinate with the main application thread javafx.application thread. So let's go ahead and try to study our java.util.concurrent package, and later we will study javafx.application javafx.concurrent package. So stay tuned with Java City. Let's go ahead.
And this is our type. Let me try to do a Maven project. So a brief idea about the Maven. Maven is a software management comprehensive tool, mainly work on a Java framework. It provides the dependency at the time of requirement automatically from its repository. So there is no need to download the required dependencies. So it simply helps the developer to doing its task in a very lots of way. It's open source made by Apache Foundation. Later we will take in deep. So Maven provides a help to developer to doing his job. So let's go ahead and try to create a Maven project. So this is a maven-r type quick start, and let me give the name of project. And this will be, of course, producer, consumer, as the working of a thread things which so, and it is already taking a download from a repository. First time when you will start the Maven project, it will take or download the required libraries from the remote repository, and after that it will create a repository at local machine, and then whenever you will call, it will simply take the libraries from the local repository. So this is a very fast way to doing a project. So you can see here a main method, and this main method here is a system.out.println. So let me delete this. There is no need of this statement. We will do a start our work. So what we are going to do here, for purpose of understanding this concept, first we have to create two classes, producer and consumer, and that classes will implement runnable because this is a task, and by this task we will create thread for producer and consumer. We will take one producer and two consumer. Producer will simply take a string of message and it will simply put in a list, and immediately as soon as it will put in a list, it will go to sleep. Somehow the producer will suspend himself. This is, we are pretending, we are making a scenario for understanding the producer consumer concept. So producer is simply taking a message from an array in a list, and after taking a message, one message in a list, it simply halts for go to sleep for a while, and after that it will simply again wakes up and starts the work, and it writes the end of file, and in a for loop it goes on repeating the work, and in this time, which is a sleeping time of a producer thread, will simply taken as a chance by consumer thread, and will simply consume the written message in a list, and it will try to remove this. As soon as removes, again the consumer will write the second, and in the next step second, the consumer will again try to remove this, and this the process going on. So we will understand how this works and how the two threads manage these works, and how the java.util.concurrent package have been given the chance to do so. So this is our class my producer, and this have our two fields. First we have to take a list, and list will be of course type string, and this may be given as a name buffer. Okay, so let me try to import this. Java.util, and this is a and another field which we are going to take for this is a console project. So let me try to introduce a color class which will give a color to the thread. So let me try to create a class thread color here in this package, and this will be named as we have done in a previous. Okay, so let again we come in a producer consumer, and here we are taking a field private string color. Let me try to make a constructor. So public my producer, and here we will have a two parameter constructor. One will be of course a list of string, and the name will be same buffer, and another will be string, and parameter will be of course this one. And so let me initialize this inside a constructor this. So as already we have told, this word simply indicates current object. So this dot buffer indicates the current object field, and this will be parameter passed. Okay, and here again this dot color equal to color parameter. Okay, now let me implement runnable. So runnable is the interface, and it has a run method. So we must have to implement run method. So let me write a run method, public void run, and this is a run method. So, and here in this run method, this producer, we are taking simply array of string. So string array, and this will be called as nums, and this will be initialized with strings. So let me take it 1 and this will be second string, this will be third, and let will be 5 elements, suppose 4 1 2 3 4 5, and this is a suppose 1, and here it is 2 3, this will be, and this will be 4, this will be 5. So 5 elements we have given here in this string. Now let me take a for loop, and here this for loop will start, the variable name is num, and that will go up to nums. Okay, what it will do, it will go and it will try to add in a this buffer this number. It will iterate through the array of string nums, and one by one it will. So before going ahead, let me try to print, and here what is going to print, this will be first we are taking to this one, and we are going to print adding, and after that here is it what we are going to add, this num, and after that we will simply add buffer dot so now we are adding the num, and the loop will go on, and after the adding this string, what we have to uh, make this current thread sleep. So or we are going to suspend this thread, and we are simply giving the time to consumer to acquire, do its work, thread dot sleep, and this will be of course 2000 millisecond. This should be surrounded with try catch block because we are suspending the thread. Here we have to pass this num. Let me surround this try catch block, and this will be catch, and catch what? Interrupted execution. And the parameter will be suppose e, and let me print if any case the control goes in this statement, interrupted for sleeping. Okay, now after while loop, after this for loop, we are adding indicator end of this EOF. Okay, this string will be added. This will simply indicate that the all return material have been ended up. So let me give us something here, and color, and this will be adding EOF and exiting. Okay, so this is my producer we have done so far. Let me create a consumer class or consumer. So this will be a class my consumer. After some time we will, here also we will have a list of string This will be what? Buffer. And also this field need to be private, and this should also be private. What? The string of color. Let we have a constructor, and this constructor will be public my consumer, and this will be of course two parameter constructor. One parameter will be list of string, and the name will be of course buffer, and the second parameter will be string of color. Let me initialize this. So again the word this, very useful word. Again reiterating that this indicates current object. Okay, this will be equal to the parameter passed, and this dot color equal to color parameter passed. Now let me implement runnable. And why we are implementing runnable? This is an interface. This simply shifts a consumer task, and based on this task we will create thread. We have to implement this run method here in this class. So public void run, and here in this what we are going to do, we will create a always true while loop, and first we will check the condition if the list is empty or buffer is empty. If this, so if buffer dot is empty, if it returns true, then no need to do anything. So go in a loop, condition true, and it will go out. Next condition is if buffer dot get, if the first element is already dot equals EOF, then what we'll do, it will simply go out. So let me print color plus exiting, and this should be break here, because already end of file have been here. The we have passed a variable, so this variable we will discuss later. And now if the things will do like that, if both the condition is not meeting, so the thing we have to do, what we have to do here, buffer dot get 0, it means the first element dot remove. Directly you can call remove, and this will remove what? The element, this one. And here this will be a curly bracket, and here we have to we are simply we have to write color plus removing plus buffer dot remove 0. Okay, the things have been, there is no need of this one. So this is a while loop, and here this need to be tackled. We will create the main class static final variable EOF. This will be public static final string, and this will be EOF is equal to EOF. Okay, this is, so you can see, let me import this. This should be Alt plus enter. Now you can see here it should be ended up, closed up. Okay, so I hope the things have been done. Why it is so? This is redundant, so no need to this one. Okay, now we have created a class, so now let me create in a main class. Let me try to do something here in main method. This should be here. Let me delete this one and let me delete this one. Okay, now it is matter clear. It is okay. Now let me delete this one. Okay, now it is somehow good. Now let me create first list of string. That will be called buffer, and that is equal to new array list. Now of course we have to take a string of color. Now we will create our consumer, and here we will pass what? Buffer and color, and this will be what? Color will be thread color. So first this is consumer, so we have to first take color that green. Okay, this will be my producer equal to this. We are creating an object, so this is new my producer. Okay, the same way we will create two consumer. So first is my consumer, my consumer 1, and this will be equal to new my consumer, and here again we will pass buffer, and let me pass the color for this one, thread 1, consumer 1, thread blue, and next consumer thread, my consumer 2 will equal to new. This is quite straightforward code. We have already done so many times, and now this will be given thread dot Cheyenne. So two tasks have been created. So let me create thread, new thread, and here we are going to produce consumer, my producer, and this dot start. Okay, now again a new thread for consumer 1, my consumer 1, and dot start. Now again next and last thread for consumer 2, my consumer 2 dot start. So this is quite old way of handling thread interference. We haven't visited java.util.concurrent package so far, and now here we will try to understand in a producer consumer example what the situation comes and what are the drawbacks of synchronized block, and how java.util.concurrent package helps us an easy way to handling all this thread interference and abnormal situation. So we have created a thread and we have started the thread in a main. So I suppose all work have been done. So let me try to run it, our program, and want to see what happens. This is a base program, my consumer, my producer and consumer, and we want to see the thread interference happening in this program. And after that we will try to remove this interference. We have already taken a console. Okay, so let me run it again. You can see adding 1, removing 1, then there is a thread 1 index out of bound exception. After that producer is continuously adding, and the consumer is not able to get the lock of object, so it is still running. The program is now in a halt state and the execution is on, but we are unable to conclude. So let we stop it, and this list is getting added by producer and it is again taken by consumer to check for the purpose of checking. So we must have to synchronize this list. So list is, so first we have to go to producer code, and here in this code, let me try to synchronize this, and here we have to buffer, and after that we have to this code you can see, and we have now synchronized inside a synchronized block. Now again this buffer, so here also we have to synchronize this buffer, and this one let me try to include inside this. Now here you can see this, and here also we have to synchronize this one, and let me try to add all this code inside this one. Because in almost all lines buffer list is required. So here we have done so far. we have to add this one, and we have to just go. We have twice called this method buffer.remove. This is the problem we are facing here. So we must have to delete this one. Now the problem is okay, because once it is removed, there is no meaning of no element is there. So we have to just wait for this one. Okay. So let me run it again. You will see somehow this thread out index out of bound exception will be. So you can see here it is running fine. Okay, the things is going well. Adding one, removing one. Okay, we have synchronized the critical section of a code buffer. So the things is getting well, but the main thing is there is a problem in a synchronized block, that it can't be interrupted while the thread is getting executed or working. Also, we are not getting any information about the thread. If number of threads are there, how much time they are going to wait, or which thread is waiting since long, or is there any scheduling interference, or is there any priority for scheduling of a thread. So what we have to do, we have to employ java.util.concurrent lock, and we have reintent as the lock is already kept by my producer. So we have to use a object of reintent lock. So this, and let me call this buffer lock. We have created object of buffer lock. So rather than synchronizing this block of code, we have to employ this buffer lock dot lock, and after that we have to employ buffer lock dot unlock. Okay, now there is no need of this synchronized block of code, and same thing we have to do here also. You can see we have to delete this one also, and we have to unlock this to dot unlock. So we have done so far. We have removed the synchronized block of code, and now we are trying to, now here again we are, let me again reintent lock buffer lock. Okay, now let me again call a buffer lock dot lock, and if this buffer dot empty is true, the loop will goes inside and it will simply go outside of the if loop. So we must have to use here also buffer lock dot unlock. We must have to use it before continue, because after that the execution will never go to this one. Okay, here also we must have to take this one inside. So before going here, we have to test. Before going to here, buffer lock dot unlock. And now if this goes in this one, we must have to buffer lock dot unlock. So you can see okay, we have done. So we have used a reentrant. So as the name suggests, reentrant is a lock which is kept by a thread but haven't been unlocked. In the meantime, if suppose another thread want to lock it, the lock of object of a lock of object. So in that case, this reentrant lock, this lock will be provided to that thread. And again, suppose the thread which is owning the lock of object will again wants a lock of object, it will again get the lock. So this is a class and its object. So let me try to produce. So here we have to, in a producer consumer, here we have to reentrant lock buffer lock, and we have to use modify the constructor. The same thing need to be done here in producer 2. The constructor need to be modified, reentrant lock buffer lock, and here this should be initialized this dot buffer lock equal to buffer lock. So we have already modified and we have employed a lock unlock method. So let me go in a main method, and here we have to create object of this one buffer lock. It should be very same, equal to new reentrant lock. Now here we have to give the object of reentrant lock. So this should be buffer lock. Here also it should be buffer lock, and here also it should be buffer lock. So all we have done, we have employed a reentrant lock object buffer lock. This will have a method lock and unlock. So rather than using synchronized block just to getting rid of all the problems which we are facing due to synchronized block of code, we are using buffer lock dot lock method and buffer lock dot unlock method, and we have made changes proportionally in producer and a consumer class, and corresponding changes in a constructor of my producer and my consumer class. And here we are in position to run the program again. So let us see what changes comes, whether the program is getting executed or not. So you will see we have used java.util.concurrent.lock package and its object. So you can see when we are running, the program is going, and a producer and consumer. The consumer is consuming, this is thread 1 blue, and after you will see thread 2. As soon as it is getting the lock of object, which lock of object? Buffer lock. Buffer is a list, so it is getting executed. So sometime what happens, we are making lock of an object, and as soon as the work is over it must be unlocked. If it is not unlocked, then you will see there will be error. And what kind of error? Illegal monster. If the lock is not getting unlocked, on that case the second thread will wait. If this go, you can see the things is getting happen because the lock is already kept by a producer and it is not getting released, unlocked. So on that case, the lock is not getting passed to consumer thread, so program is not working as it should be. So it is always better to unlock the taken lock, and it should kept within a try finally block, because try finally block is whatever the code executed in a try, in any case whatever the result is, the finally block will be executed. So on that case there will always be the lock will released. So let me see here what we have to do. Here we have to try and finally block. So this is always a good practice to imply. Okay, and here the finally this code block of code unlock need to be kept inside this one, and both the code this they should be kept in a. So in any case, if we forgot to unlock, or suppose the thing is not getting executed, so on that case the thing will go on in a proper way. Here also we should employ this one, and let me these two code need to be kept here. Okay, and already we have taken a finally block, so this is okay. Let me check whether we have forgot to okay. Now we have already done this, and the same need to done here. So we have to employ try, and this should be finally, and here buffer lock. All the code which we are employing buffer lock, this one need to go this one. Okay, now this should be inside this try block, and here we don't have to, this unlock will become here, and here we don't need to unlock, because in any case this finally block will be executed. Either the program goes inside this or inside this or inside this. So let me try to execute, and we will see the results will be expected as in a line as we are hoping. You can see that things are going in a proper way, and perhaps it is executing in a as we want. Let me run again. So adding and removing both are going in a synchronous way, and the thread is getting locked and unlocked. You can see both the threads are doing their work. Okay, so this is lock, and so buffer lock is a reintrant lock. There is again a method try lock, and if the lock is acquired someone by someone, so better to wait for a lock. We have to use a method try lock. This try lock method will try for getting a lock of object required, and as soon as it will get, it will execute the work, and after that it will release the lock. So let me here try for the lock if buffer lock dot try lock returns true. On that case, this will go ahead, or you may say, so there is no need to lock again. Okay, it will do the work like this one, and after this finally we have to check while, and this is a while method, and here we have to, okay, now what we have done so far, the lock is already kept by this producer, and let me the consumer want to take a lock. So rather than trying, we already have a method try lock. This will return to, then only it will execute, and once it will try the code which is inside the if block will get executed. So let me try to execute this one. This is a method given in a java.util.concurrent.lock package, lock, unlock, and try lock method. There are so many utility methods there, and based on the requirement you can use them. So the things are getting executed as it is, it should be. Let me run it again. So try lock is a method which continuously tries to get the log which is required, and you can see also the counter how many times it is returning. It is not getting the log. So for the purpose of understanding, let me check. Let me take a counter, and that should be initialized with 0. So suppose it is my consumer, and in this run block, if suppose this it requires the lock, it tries for a lock and it gets the lock, and this one, right? Okay, so now we have done so far. So you can see, let me try to run it. Let me try to run it. You can see, right, for a number of times this one, and this is going in a millions of number of times in a millisecond. So you can see how much time and how frequent the thread is trying to get a lock of an object. And if the number of threads are trying for a same lock, so you can see the quarreling of a thread. So we have already taken a try lock method. So class, factory class executors, and there is the number of utility methods there in executor class in java.util.concurrent package, and there is a interface executor service. So that executor service basically create a service like a runnable task, and it will take a runnable task and work like a thread. So let me try to create a, there is no need of this one reintent lock. Okay, so now we can do no more this one required, and we can use our executor service. So that we delete this one executor service, and here it is executor service. You can see this interface, and this is executor service, and we can use factory method executors dot new fixed number of threads. So this factory method will return executor service and it will confirm the number of threads, managed threads or optimized threads created. So here we have require a number of threads 3. So let me make it 3, and also there is a, you can see this thread factory, and also there is a fair lock threads to know. Now we don't need any buffer lock. So let me delete it. In trend lock object. So let's explore more java.util.concurrent package, and here we have done so far and executed the program, and it is running in a very fine manner. So the next thing is, let me reduce first and delete this counter because no need to check this one. So here in a consumer code, let me eliminate this counter because we already checked this one. Okay, so reintent lock is now doing well, and the producer thread is acquiring the lock, and consumer thread when it requires trying for the lock by the method called bufferlock.trylock, and it is getting the lock on the period when the producer is sleeping, and try finally block ultimately is unlocking the buffer lock, releasing the lock, and it is getting acquired again by producer. So java.util.concurrent package provides a factory method executors having a where lots of utility methods classes which can be used for creating a thread. So a developer no need to worry about the creation of a thread and optimization of thread. We have already a method provided by Java library. So let me create this executor service. So this is like a thread. We already require this, and this executor service interface will be created by the factory method executors dot new thread pool. So you can see there is number of methods provided here. New thread pool int number of threads. So as many threads we have to we require, we will simply give an int. Here we are using number of threads 3. So this will enable a developer to make thread optimization when the thread and the block this unconfigurable executor service and new fixed thread pool. This is number of threads, thread factory, and new single thread executor. So number of methods, this is up to you, and this is completely based on practice how much. So this we have to create 3 threads, and instead of creating this thread, let me delete this code, and now we will call executor service dot execute, and here the runnable is this is for my producer, and this will do what? This will create a same type of work, new thread, and will take a runnable type of class my producer dot start. So it will execute. It means it will take the runnable task and start. So the same thing need to do for the consumer threads. My consumer 1 and my consumer 2. Dot execute, and this is my consumer 2. So this will do its work and rest of the things. So we have called executor service the method, and why it is showing some problem? Is there any problem? Okay, this is creating a problem. We have just deleted the counter. So forgot to. So let me try to run it. And I hope the things will go on as it is. You can see, okay, this line need to be removed. So thread removing, adding 5, removing 5, exiting. Okay, now the program is still running. It is not terminating. So the one thing most need to first we will delete. Okay, let me minimize it. First we have to remove the counter code tried for this one. No need of this one. Okay. Now the executor service has started and performing its task, but after the completion of task, it is not releasing the thread. So the main thread is still working on, and in a background, the rest of the thread has completed its working, but they are not getting terminated. So we have to terminate the thread manually. So we have to call again a method executor service dot shutdown. So this method will simply terminate all the threads after completion of their task. So you can see, let me again run it. Now I hope the program will terminate in a proper way. So adding 1, removing 1, 2, 2, 3, 3, 4, 4, 5 and 5, exiting, and this is end of exit code 0. So this is properly terminating now. So we have taken executor service and created a shutdown. Another important thing which need to study here is this is a collection class array list. So this array list, so let me see the array list docs and you can see this last line. This class provides methods to manipulate the size of array that is used internally to store the list. This class is roughly equivalent to vector except that it is unsynchronized. So array list is not synchronized. Whenever we are using array list in a code, we have to keep in mind that this list need to be synchronized. So for doing so, java.util.concurrent package has provided a blocking queue and lots of classes, and we can see here this blocking queue we can create, and this is a blocking queue in all implementing class, a queue that additionally supports operation that wait for the queue to become non-empty when retrieving an element and wait for a space to become available in a queue when storing an element. So blocking queue methods come in 4 forms. This is all the method. So we have to some modify. So here you can see this provides uses example based on a typical producer consumer scenario. Note that a blocking queue can safely be used with multiple producers and multiple consumers. So this is a thread safe mechanism. Blocking queue has been provided. So rather than using here array list, let me modify and change this as a blocking queue. So let me change this blocking array list Okay, now here we have to change this one also, blocking queue, and in the same way we have to change the consumer also. And here also we have to change, and once it is used as a blocking queue, so on that case there is no need of reintrend lock, so it automatically manages. Or so let me eliminate this reintent lock. So now this need also, there is no need of this one, so let me eliminate this buffer lock to reintent lock from here constructor. So from the here we don't need this, so all the code need to be deleted from here. Very simplified code here. This is the advantage of taking blocking queue. Buffer is now a blocking queue. So in this here we have to, rather than using add, we have to use what, dot put, and this way we have to use this num, and we have to use this one as a try catch block. And we will have a catch, and here is we have to use, if this is suppose exception, execution exception, any exception or any execution exceptions already we have cleared. So why it is unhandled, why just we have just handled, then why it is showing. Okay, let me wait for some time. And the same thing here, we need to do this one. And this buffer dot add EUF need to come inside this one, and here we have to catch block and execution exception. Okay, first we have to change the method, that's why it is calling this one, and this is put method. Add interrupted exception to catch with execution exception. So we have to add one more catch block too, and this is a catch block with interrupted execution. Interrupted exception. Interrupted so we need to put this one also here. catch block again, interrupted exception. There is no need of this one too. So we have to delete from constructor to, and this buffer lock, then try lock, no need of requirement of this one. Now buffer dot, this buffer is now this, so we have to take peak, and this will work as we want, and here the remove method will be as it is. So I hope why this is showing interrupted, add interrupted exception to catch with execution. So and here we have to object of this one, this is there is no need to delete this block of code because already we have added. Let me modify this too. So blocking queue, we have already this made this. If buffer is empty, continue the bar this okay. Already we did all the things. This should go try catch block. There is no try. Only we can do this by this way too. And here we are going. Let me delete this. Now, what is the problem? Why it is showing some problem there? Let me check it. Okay, this is the problem. So let me eliminate this. Okay. Now we have to remove from this reintent lock. No further requirement of this reintent lock. So let me delete this. Delete this. Blocking queue is new. Array blocking queue. This will be of type string. and here how many queue will store how many number of string items need to be initialized first. So here total 6 items need to, so we have to, you can see this creates an array blocking queue with a given fixed capacity and a default access policy. So we have to define this one. So buffer dot remove, so this is not a blocking method. It means it will remove even though the element is not available. Since the two consumer threads are working in a same blocking queue, and a blocking queue is a thread safe, it means it will ensure that the thread will be complete. The method call before the thread 2 is allocated this queue, but during these 2 3 methods in between these two, the thread is getting suspended, and in meantime the another thread may be acquire the queue. So here it checks the peak method and remove. So to remove the method, we have to check, we have to use a method take, because it is a blocking method. It means, so on that case we have to surround this with a try catch block, because if this method call will be there, the another thread will be suspended for a while, and after that completion of this one, the method call will be allowed for the next thread. So peek and take, both the methods don't take any index, because the queue always works with the FIFO principle. It means it works for the first in first out, so there is no matter, it always starts with the first element. So I think the null pointer exception will be handled out, but there is already a problem that if thread 1 is getting calling this method, and again after the execution the thread will be suspended, and suppose the thread 2 will get this method. In the meantime, this thread will if this thread 2 will get this method call, so if it only detects that it is EOFs, and they will delete, and again the next thread 1 walks up and call this method, so on that case this will return null. So there may be a chance to return a null point exception, because thread save queue will ensure that both the threads will be allocated till the method call is getting completed. But in the meantime, thread may be suspended, and if the null point exception is coming, so the best way is to ensure the total buffer synchronized till the call is getting completed. So let be okay. So this is synchronized now. So now the all things is over, and it should run with. You can see the things are going in a better way, and there is no need of any reintent lock. So we are using all the blocking queue methods for ensuring the thread safe mechanism, and the process should go on. Let me run it again. There is no null point exception, and both the threads are working in a synchronized manner, and they are doing their work in a proper way, and then exiting after completing the process. So I suppose the thread management is quite big chapter. Already we have taken a long video, so this might give a brief idea about the thread management and interception, and how the thread safe mechanism may develop. Rest more things will be covered in a final video about the threads, but the most thing is that getting practice with the threads, and the producer consumer example is the most suitable environment for understanding thread interference and a deadlock or a race condition. So I hope some ideas might have been grabbed by you all. So let's go ahead and wait for the next video. We will complete and conclude the thread concurrency and thread in a next video. Till then, stay tuned with Java City and bye for now.